In this example, we want to find the exact value of the remaining trig functions when we're told that our sine of theta is 12/13 and our angle is in quadrant 2. So let's go ahead and draw our triangle. So we have a right triangle here. And we're in the second quadrant. So we have theta. Theta's here. And we're told that the sine of theta is 12/13. Sine is the opposite over the hypotenuse. So we don't know this adjacent side, so we can use the Pythagorean theorem to figure that out. So we can say a squared plus 12 squared is equal to 13 squared. So that's a squared plus 144. Oh, that's bad. Plus 144 equals 169. Subtract 144, we get that a squared is equal to 25. Take its square root, so a is 5. So that tells us that this measure is 5. However, the direction, right, the x coordinate in this direction is negative, so it's going to have a negative value, or negative directionally. So now we can use this triangle to find the remaining trig functions. So we still need to find the cosine of theta. We need to find the tangent of theta, the cosecant of theta, secant of theta, and the cotangent of theta. So cosine is the adjacent side over the hypotenuse, which is 5/13. And then again, it's in the negative direction, so this is going to make it negative. We also know that in the second quadrant, the cosine is negative. The tangent of theta is the opposite over the adjacent, so it's 12/-5. So 12/5, that's negative. The cosecant is the reciprocal of our sine. So the sine is 12/13, we are given that. So its reciprocal is 13/12. The secant is the reciprocal of the cosine, so it's negative 13/5. And the cotangent is the reciprocal of the tangent, so it's negative 5/12. So we just used the fact that we were given the measure of the sine and that it was in quadrant 2. Then we used Pythagorean theorem to find the last side of our right triangle and use what we know about trig ratios to find those.